Ha 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 ha. Ha, yes, I got you again. I got you again. Ha ha ha. Okay, all right, I was asking, how's everyone doing? We only have about 11 people in the chat here. I think most, even people in the second section, typically tend to prefer getting their lecture a little bit earlier, but that's okay. We got a smaller group. That's awesome. How is so you're doing great, Josh Campman? That's awesome. Has anyone in the chat watched their video feedback yet? Have you watched a little bit of your peer feedback? I know there's a ton of hours to go through. Has anyone watched their instructor feedback? Has anyone got to the point where they're being driven a little bit mad because they are they're watching players get themselves confused, and they're like, oh no, you just gotta go that way. No, you gotta press that button. Oh, you gotta read the README. You didn't read it. I got some good comments, especially from the instructors. That's good to hear. Gagan says, did you guys record in the same room? I was confused about who I was listening to. No. What happens is the instructors all play the game at the same time, and we talk to each other over Discord. So we will have conversations with each other. We'll discuss, issues with the game, potential fixes, ideas for changes, stuff like that. We'll talk a little bit more about how you should take this feedback in a sec. The short TLDR is that you shouldn't let us design your game for you, but we will give you ideas. We don't want to just present a problem without presenting potential solutions as well. Also, how do we get the feedback from the other teams? If you look in your email inbox, you should have an invite to a spreadsheet for your team. It should have came from me about a week or so ago, a handful of days ago. And if you look on there, you'll see that it has filled up by now with a ton of links to video files. Whenever anyone submits the form, it goes onto that spreadsheet for you. And you can look on it. Instructors can look on it too, so that we can see who's doing their playtests and who's not. So we can apply some penalties, okay? All right, good. Okay, let's get going. We had some issues. We might end a little bit early today because we had some issues with the first section that cut our time a little bit short. But we'll get going all the same. So it sounds like P1 Gold Spike is P3 Gold Spike is going okay, and that's really good. Some quick notes on the topic of your playtesting videos. We looked through some playtesting videos last night, and we noticed that there's some issues that crop up. Please check your audio, okay? Please, before you do any serious recordings, do a little 60-second recording where you do some audio tests, and then watch that footage to make sure your microphone's picking you up fine, your captions are working, stuff like that, okay? We saw some videos that just have audio that it's totally imperceptible. It's just way too quiet. Also, many videos weren't made available to the staff, and that's a problem, right? We need to be able to check to make sure you did your video. So please go back, look at your videos, and say, okay, is this accessible to my peer team at the University of Michigan? But is it also accessible to my instructors? So A. Arger at umich.edu, A. Renton, Ishwar, Elsie Lowry, okay? We need that just to be able to grade you, okay? So please go back and fix that if it's not fixed. Okay, you had a grades released on P3 Gold Spike last night. We are going to try and make this a recurring pattern. We want to have your feedback to you as early as possible in the week so that you can use our video feedback to generate tasks as early as possible. So we'll try and have all that feedback to you Tuesday around midnight. As the semester goes on, it's going to get later and later on that night because it takes us longer and longer to play through your games and give impactful feedback. I recommend that you schedule some midday Wednesday meetings if you can, maybe even right after lecture with your team, to kind of go through the feedback, kind of summarize it, and then generate tasks based on that feedback, okay? I also recommend when you're watching your peers' feedback, there's the little ×2. You can watch at double speed. I encourage you to do that. You'll get through a lot more footage that way, and you get more information. Okay. Note, in your weekly feedback, never let your instructors design your game for you, okay? It is your project. This is a very creative course, and it is an MD/capstone course. We want you to really own this final project of your college career. And so, while we will help you identify problems in your game, and we will provide solutions, you don't have to take our solutions, okay? You can remix them, you can go in a different direction, you just have to find a way to solve your problems. We'll provide ideas, but you don't have to take them, okay? This is your project, not ours. Okay, a couple interesting announcements before we get into the main content of the lecture here. Yeah, if you thought it was a little bit strange for Google to be getting into cloud gaming, and Amazon to be getting into cloud gaming with their Amazon Luna service, Facebook also intends to get into cloud gaming. I'm not sure if they already have, but they last semester around this time, Jason Rubin, who we know is the creator of Crash Bandicoot and Naughty Dog and Jak and Daxter, and also a Wolverine alum, this guy was hired as Facebook's VP of Play. And he announced that they were rolling out cloud gaming that was instant free, no subscriptions, and no controllers. In other words, it doesn't sound a lot like gaming, and I'm not exactly sure what this ended up being. But yeah, I guess Facebook is now another traditional tech company that is interested in the gaming space, particularly in the cloud. So anyway, it's just spreading and spreading, which is pretty neat. Okay, another interesting piece of technology history is Doom. So who's heard of Doom? Has anyone played Doom? We have a message, CM Page. It sounds like it might be the text message gaming stuff that Apple does. Yeah, I'm guessing it's going to be something like that. And that might make it much easier to provide those games in an instant fashion. Has anyone played Doom, right? I imagine you've all heard of Doom. This is the classic horror, not horror, it is the classic first-person shooter game. One of the first released. I think Wolfenstein preceded it. But what's interesting is that Doom's source code has been released to the public, which is really, really, really cool. And as a result of this, Doom has become something of a benchmark on which you can judge any new hardware that happens to have a screen. So before we get to that, though, John Carmack released this Doom source code. He wrote up some notes on how to use it, why he released it, stuff like that. So if you're curious, it's all written in what is apparently portable C, so it is pretty easy to compile for various hardware, and you can play around with it if you want to. This is, because Doom is available publicly, it is open source now, and because Doom was written to be portable, and because it has such low and optimized rendering and computation requirements, Doom is one of the first pieces of software to get ported onto any piece of hardware that has a screen. How about US voting machines? Why not? Let's find out if it can handle Doom. It can, okay? You too can play Doom while you vote. Let's check out what do we got here. How about a juicer? You're preparing some wonderful healthy juice. Why not play Doom while you wait? So this is a video actually of an interface where it is a touchscreen based interface, and the player. It looks like the touchscreen is kind of like airliner touchscreens, and that they're super laggy and not very interactive, because this player struggles to turn themselves. Yeah, it's a little bit unfortunate, but it looks like it's running okay. All right, that's pretty cool. Okay, what else do we got? How about microwaves? You're heating up your burrito, right? You're heating up your burrito, and you're a little bit bored. So why not play a round of Doom on your microwave? Yeah, that's pretty incredible. Anyway, there are a lot more hilarious locations that Doom has been ported to, including the Mac touch bar on the bottom of your, right above your Mac keyboards. So go ahead and Google that. You'll find a lot of really, really funny stuff that's very interesting. Okay, so I found a documentary not long ago on the topic of Crash Bandicoot. We were just talking about Jason Rubin, who created Crash Bandicoot, the Wolverine alum. As it turns out, Crash Bandicoot was an early PlayStation game, one of the early 3D games, and the team achieved this incredibly beautiful result for the time, and it still looks pretty good today. The way that they were able to do this was by doing some of the craziest technical techniques I've ever heard of. Absolutely hilarious techniques. They were so constrained for RAM that they took the library that is automatically loaded into RAM, the official Sony PlayStation libraries, and they said, you know what, I bet we're not using all of this. And they said, we're going to cut out part of the library, we're going to use that. That's our memory now. I hope the game doesn't break. They didn't have the source code for this library, they just had the blob. And so they managed to get a little bit of extra memory into their pockets by using this technique. So I'll show you a little bit of this documentary, and you can watch it on your own if you like. Okay? We'll go ahead and turn off the lo-fi study music here.
Memory was so short in Crash Bandicoot that I took to stealing little bits and pieces of extra memory from the Sony libraries. I would just try erasing parts of them that I thought I wasn't using and see if things still worked. If they did, I would mark them as available. I just hacked their code by just changing the byte codes. And I'm like, you can do this. Look, I've fixed it. If they wouldn't fix it for me, I was just gonna edit their code. It was free memory. The memory was finite, but you were definitely not supposed to do that. Hi, I'm Andy Gavin, co-founder of Naughty Dog Inc. and lead programmer on Crash Bandicoot. We set out to make the first 3D character platform action game, and to do it right, we had to literally hack the hardware.
Okay, so if you really want to look into how just the wonder of making such a technically impressive game on such a limited 3D hardware, I really encourage you to watch the rest of this documentary. I think you'll find it to be extremely enjoyable. Though I'll be honest, it's really, really surprising to me that one of Sony's most prolific studios, right, with one of their premier launch titles, could get access to the source code for these C libraries so they could customize it and take out the stuff that they didn't need. I have to wonder why their relationship with Sony was so frosty when they were so important to Sony at the time. Maybe Sony didn't realize just how impactful this game launch would be. Okay. So, a quick reminder, not too long ago, we got a really good example of why iteration and feedback is really, really important. And not just getting feedback, a lot of it, quantity, but also getting a great diversity of it. So it wasn't too long ago when the world was introduced to... is there a name for this character? Is this the Manhog? Is this... this isn't Sonic, is it? It's definitely not Sonic. It might be Sonic. But this was the first trailer, and in particular the first character design for Sonic in the Sonic movie that Paramount announced not too long ago. Well, Paramount announced this trailer, and the internet essentially exploded. They did not like the way that Sonic had human teeth, and Sonic had really kind of smaller eyes that are more realistic and not as cartoony. The problem was, in lacking gloves, right, just having gray hands suddenly, the problem was they'd taken a cartoony character and they had sort of made him more realistic, but to the point where Sonic was right in the middle of what's called the Uncanny Valley. This character is clearly still a cartoon, but it also has weirdly realistic features, and so it kind of sets off the alarm bells in your brain to say, that's creepy, that's probably going to hurt me, okay? If you look at this instead, the enormous eyes, the gloved hands, right, the expression being more cartoony, essentially convinces your brain that, yes, this is not a real thing at all. I don't have to fear this. It's just adorable. So the takeaway here, at least in the context of this class, is that I guarantee you that there was an iterative process for this character design. There were probably a lot of sketches drawn up, and internal to the team, they probably decided that this was fine. This was going to work out. The problem, though, was that within their little bubble, they had been iterating and getting feedback and improving. However, they never really got a lot of feedback, or at least didn't listen to it when for people who are outside that bubble. So they produced the entire movie, and then they finally had to playtest with people outside of their bubble, and they discovered that, wow, everyone hates this. They then had to go back in, and they spent, I think, like $5 million, which isn't that much for replacing your main character in a CGI animated movie. Go back in and make huge changes, and the movie ended up turning out pretty well. It would have been cool, though, if they had known to go for this from the start. Okay, so anyway, a very high-level example of iteration and feedback not quite going to plan in the context of a AAA Hollywood movie. The Uncanny Valley can be a bit tricky. The Uncanny Valley is a very, very interesting kind of psychological topic. I encourage you to Google search it. There are lots of really great, creepy YouTube videos that you can watch online on this topic. All right. This version of Sonic kind of looks more like a human in a Sonic suit, which is pretty creepy. But anyway, okay, let's go. Something to note is that as we move forward through Project 3, your criteria for your assignments is going to change. If you go to all of your rubrics, if you get all your information from the schedule, and I don't blame you for that, then you can get to the assignment specs, but you can't get to the assignment rubrics, which are on Canvas. I really encourage you to look at Canvas, particularly toward the end of an assignment, and look at how exactly you'll be graded. What you'll notice is that over time during this project, more and more criteria will be added onto your rubric. This last week, P3 Gold Spike was simply all about identifying what your Gold Spike mechanic is, and then completing it and completing the game loop. Okay? But now, this week, with P3 Milestone, you will be dealing with guidance, you'll be dealing with interesting decisions, and more of those kind of standard criterion will kind of seep into the project. Okay? The guidance criterion is typically mixed in with the technical criterion. So just because that metric is low doesn't mean that your guidance is necessarily poor. It could mean that your game has many bugs, and also vice versa could be true. So make sure that you watch the video feedback tutorial from both your instructors and your peers if possible, so that you know what's up, right? Know where your points are going. Okay, I won't take you through the P3 Milestone spec. It is very similar to the other kind of general like P2 spec that you've seen, P1 specs. So make sure you read through it. The P3 research assignment that is releasing today is not due for about 2 weeks, okay? So you have some time to talk and debate with your team about, okay, what genre are we really going to be in? And then once you have nailed that down with your team, and you can change it later, you can mix and match it later if you want. You don't really want to, but hopefully you don't have to. But once you know roughly what genre your game is probably going to be, you need to write a 5-page paper at minimum that is going to compare 8 different games to one another. And by 8, it's kind of a pairwise thing. So you're going to find 8 different games that are in your genre, okay? If you are making a racing game, do not compare a racing game to a rhythm game. Do not select a fighting game, okay? Unless you have a rhythm fighting game, and then both genres will count. But you will find 8 different games that are hopefully in the same genre that your game plans to target, and then you will compare Game 1 to Game 2, and then you will compare Game 3 to Game 4, 5 to 6, and then 7 to 8, and then you're done. Okay, you probably want to split this up among your teammates, and then at the end of the assignment, you come back together, you discussed what you learned, and as a result, despite this having a lot of games and a lot of pages in terms of its length, it's going to be a really short assignment for you, okay? you'll be writing probably like 1.5 to 2 pages per person on your team. Double spaced, that's not a big deal at all. Okay. Any questions? Any questions? Okay, I think we're good. Okay, so let's go ahead and get back to the lecture plan. It's become really clear from playing your games and just kind of reading some of your feedback in the comments in the chat that pathfinding and AI is going to be a big deal for many of your teams. Many of your games have these mechanics where you have something like a guard walking around or an enemy walking around, and if the guard or enemy sees you, they have to give chase, or they need some way to get to the player. You know, they have to know to go around a block that's blocking them. And so this can be a really tough challenge. There's a lot of really interesting algorithms and data structures that go into creating a robust pathfinding system. I haven't told you this yet. Well, I'll tell you this in a little bit, but on The Sims 4, pathfinding was considered a core system, and so we dedicated like 10 people to making sure that it would be robust, it would be performant, it would be flexible and scalable, because you have to have up 50 Sims in an environment, and they have to know where to go. They have to walk around each other. They have to do all this stuff, and so pathfinding can be a really big deal. However, you don't have to implement your pathfinding from scratch. You can do it, and it's pretty easy if you stick to 2D. Custom approaches like A-Star can really help you out there. But what I'd like to do today is I'd like to show you how you can really, really, really quickly get up to speed and going in a fresh Unity project with some basic pathfinding. Okay? So let's go ahead and open up our Unity here. Go ahead and open up our Unity. I'm going to grab something real quick. I'll go AFK for just a second. Okay. I'm going to go and... Okay, there we are. All right, now I'm coming back. Okay, so let's go ahead and create a new Unity project. I'm going to call this Pathfinding 4. Okay. So we'll wait for Unity to load up here. This often takes a little bit of time. I want to ask you, I would like to do more of these kind of mini lectures where we explore a quick implementation topic. It's hard to know what to do because so many games are so diverse and different, and every team needs slightly different stuff. So the question while we wait for Unity to load up here that I have for you, chat, is are there any topics that you would like us to explore? Any kind of implementation tricks and techniques? Any interesting game mechanics that you're trying to implement but don't quite know how? Is there anything you'd like to see in a little mini demo in the future? Smooth, nice camera controls. Oh, yeah. Yeah, that can be a lot of fun. There are a lot of different kinds of cameras, and there are a lot of different ways to make a smooth one. Like a third-person orbit cam can be really fun to do. You use a little bit of trigonometry to make a cam kind of go around in a ball, around a player in a ball. User interface tips. Yeah, user interface can be a real pain. For Arbor Interactive games, if you play Greek... No, it's not in that version of Greek Tragedy. We have our own UI system that makes it really easy, like one function call to generate a menu that you can then like move around the screen like a window. And so UI is a tricky topic that takes an enormous amount of time, but can be kind of satisfying once you get it right. User interface tips, definitely UI. User interface tips. Okay, so we gotta, user interface is the golden ticket here. Let me open up my notes real quick. Okay. Create mini lecture on UI tips. Okay. Is there anything in particular that you want to be able to do with your UI? Oh, Ishwar has a discussion on UI planned. Okay. No, that's okay. I think that we should probably talk, though, so that we don't duplicate and clobber each other by covering the same topic, Ish. Okay. Give us a preview, Ish, while we wait for Unity to finish up here. Gosh, 2 minutes? That's outrageous for a new project. What are you going to be covering, Ish? Okay. So Ish will put that answer in there in the chat. Let's go ahead and get going. So we have our empty project here, and we need to get a little bit of basic setup going. First of all, let's go ahead and create our little environment, our level geometry. We've got this little cube here, and we're going to go ahead and make it a little bit bigger. We'll make it 20 by 20. That doesn't look very good. That coloring is very stark. So let's go ahead and create a material. Let's just call this green. It's going to be our little grassy area here. We'll go ahead and choose a nice green. What do we like here? Oh, I like that green. That's a nice soft green, isn't it? It's still just vibrant enough, but not so vibrant as to be annoying. That's good stuff. We'll use that color as the basis for other colors, and as a result, we will get a color palette. And the game's aesthetics will just look a little bit nicer. Okay, we want to create an obstacle now. Let's go ahead and let's create an obstacle. Maybe it's going to be 5 by 5. It's going to stick into the air here. We'll bring it up a little bit, okay? Maybe a little bit lower. Let's go ahead and create a red now. So, actually, we'll make it blue. We'll make it blue so the red-green color blindness doesn't get us. Okay, so we'll go in, we're going to copy and paste that color into this one. Now, in order to create our color palette, we're not going to change the saturation or brightness. We're only going to change the hue, which we can do by only adjusting the color wheel, okay? So now we've got, oh, that's red. Okay, let's do blue. So there we go. We got blue. All right. These colors kind of work nicely together. All right. So now we need to have an enemy. Let's go ahead and create a little enemy here. We're going to create a capsule. Going to bring it back to the origin. Boop. Oops. Come on. Open back up. Unity. Okay. We're going to come to the origin here. And we are going to bring it down a little bit. We're going to give it a visor so we can tell which way it is looking. Going to create a little cube inside of it. We're going to make it kind of thin here. 0.5, 0.25, 0.25. And what is the forward direction here? Yeah, that's fine. We're going to bring this up and we're going to stick it out the front side. And we now have a character that has a little visor and some goggles. That looks pretty cute, huh? Okay, so we're going to name this enemy. Get a little bit organized here. We're going to create a player, kind of pseudo-player object here. We're going to make it this cube. And we're going to get rid of its box collider because we don't really want it to interact with the gameplay right now. Well, there we go, okay? Now, what we need to do if we want to generate a navigation mesh. First of all, what is a navigation mesh? A nav mesh is essentially you can kind of think of it as either a 2D surface or even a 3D surface that covers a certain area and contains information about how to get from one area to another. And so what'll happen is you bake an environment, and Unity or your game engine will take some time to figure out, okay, if I'm here on this surface, I need to go this way if I want to get to this other surface. If I'm over here on this surface, I need to go this other way to get to this surface, or this way to get to this surface, or this way to get to this point on the surface. And so we need to create a nav mesh. In order to do this, we'll actually need to bring in some technology called the nav mesh surface. The Unity nav mesh surface. And we can get this by cloning a little repository that's called the nav mesh components. This is a free repository that Unity provides. I have no idea why they don't include this in the built-in Unity install. But what you'll need to do, and you can return this video if you want to follow this, is you'll need to come in here, find this repository, go grab a zip file. You will then get this right here, okay? This will be called assets folder. It'll look like this, and you'll want to rename it because otherwise you can't add it into your project. So go ahead and rename it. Let's call this the navmesh components. And then we're just going to drag this folder right into our project. So we're going to go ahead and open up our project. We're going to drag this folder right in. And as a result, we're going to get a handful of really cool components. Now, some of you might be wondering, oh, we're just using built-in stuff? That's kind of lame, right? I mean, don't we want to implement this from scratch? You know, we want to understand what's going on under the hood. Well, that's awesome. We do want to do that, and we will do that a little bit in one of our final lectures on games and AI. However, right now, your goal is to create the best game you can and be as efficient as possible with your time. So we'll be using these components, which give us a lot of functionality. And if you want to know more about the cool algorithms and data structures that make this stuff all work, wait until one of our final lectures of this course, or take EECS 492, the artificial intelligence course, as many of the classical search techniques that are employed in pathfinding are discussed at length there, okay? Okay, so we've got our little player here. There we are. And we have our new interesting component. It's called navmesh surface. And it is right in here, I think. So what we need to do is we need to put these little geometry objects together. We're going to create an empty game object, a container, if you will. We're going to call this level geometry. We're going to move it to the origin of our scene, and then we're going to kind of add in our two pieces of geometry inside of it. Next, what we can do is, in order to generate our navmesh, we can go to our level geometry and we can add that component. We'll just go, hey, give me the navmesh surface. This component is interesting because it actually is sort of like a tool. You can click bake, and what will happen is it will generate this really cool and visualize a navmesh on all of your surfaces in the scene. You can see this kind of blue area. This represents the navmesh. Anywhere on this blue area, your agents, your characters, can walk around. If you're in this blue area, you can always know the directions you need to walk in to get to anywhere else. So for instance, this character will know how to walk to the other side of this cube. It will actually go around it. Now, if you notice, there are actually some problems. There are some holes in this navmesh, and it's because we made a little mistake, okay? When the navmesh is being baked, this component will look through the entire scene. I believe it performs a ton of array casting, and it will look for anything that might be blocking the way, okay? And it says, okay, well, if there's something in our way on this navmesh, then we can't include it in the navmesh. People have to go around it. We don't want our player or our enemy to be a part of that navmesh. And so what we'll do is we'll say, you know what? When you're collecting objects, right over here in the inspector, when you're collecting your objects to consider for this navmesh, only consider the children, okay? Only consider the children of this game object, as in only consider this ground and this block in the center. We'll go ahead and rebake. And boom, there we go. No more holes. All right, good. Okay, so now we have a navmesh, but I mean, we can't really use it. If we play the game, nothing will happen. Nothing will happen, so we'll play the game here. There's no sort of movement logic. There's no logic on any of our game objects that tell these game objects how to use the navmesh that we now have. So what we can do is we can add another component that is provided to us. We can go to our enemy. There we are. Okay. So our enemy over here in the bottom left corner, our enemy can be given a new component. It's called a navmesh agent. This is a super powerful component that is a way, it provides a way to move our game objects in a navmesh aware context. So what we can do is we can customize different things on this. We can say, hey, we want the speed to be more like 2, angular speed, how quickly it can turn, how does it accelerate, what's the radius? If it gets within 0.5 meters, will it can we increase this so that it'll take a wider cut going around things that aren't in the nav mesh? So we can customize all that stuff, but the last thing we need to do is we need to tell this nav mesh where we want to go. For that, we should write a new component. Let's call this desired position is game object. Okay? This is a component that, if it sounds a little bit strange, and by the way, I'll make myself invisible so you can see it down here. If this sounds a little bit strange, it's because we're trying to make this really generic. What we want to do is we want to be able to provide a name of a game object to this component, which means we're going to create a public string variable. And that name is going to determine what game object our unit heads toward. Okay? So that will allow us maximum kind of customization, customizability when we're actually playing. It'll make it easier for our game designers to use our stuff as well. Okay. Come on, Visual Studio, let's go. Let's go. Let's go. Bring myself back in the corner here. Okay, so the first thing we want to do, we're going to be dealing with navigation mesh stuff. So we want to do using Unity Engine dot, AI. This will give us some of the data types that we'll need. The next thing we want to do is we want to establish what the interface for this component is, or what the parameters of this component is. So string, let's call this target name. You can provide a name here if you want to, and this is the object that we will chase. We are going to want to only update our routing every second or so. So not every single frame, because it is kind of computationally expensive. So we're going to create a coroutine that will handle this for us. We're going to call this the render loop. No, not the render loop, sorry. Let's call this the pathfinding loop. Is the stream still working, everyone? My preview of it kind of died. Okay, we're going to have a... Uh-oh, I think I might have lost everyone. Did we lose everyone? Ish, are we good? Ish says we're good. Okay. So inside of this loop, we're going to have an infinite loop. However, that's not going to freeze our game because we're going to yield for 1 second. We're going to yield for 1 second after every iteration of the loop. In the meantime, what we want to do is we want to see if we can find a game object with this name. So game object, target game object equals game object.find. And what is the name of that game object? Well, it's whatever name our game designer puts into the inspector, okay? Once we have this game object, if we do find one, so if that variable is not equal to null, then what we want to do is we want to tell our nav mesh agent where to go to the position of our target. In order to do that, we need to capture a reference to our nav mesh agent. We'll just call this agent. All right, and then we'll go agent equals get component. We'll fill that reference at runtime when we spawn. Okay, good. And then we need to remember to launch our actual pathfinding loop. Okay, cool. Actually, you know what we could do also, which might be kind of cool? We could also make the amount of time you wait in between pathfindings a variable as well. So let's call this finding refresh interval seconds, and we'll set this to be 1.0 initially. Okay, we'll use this to determine how long we wait inside of our loop. But we will always guaranteed wait for at least 1 frame, even if it's 0. So that won't lock the game. Okay, so now what we can do is we can say, hey agent, we found our target. So we're going to set your destination to the target's location. Target.position. Transform.position. Okay, cool. So, hey, let's see how it goes. So we have our enemy here. We have our enemy. It has a desired position as game object. We need to fill those variables here. We need to give it the player. You should go find the player. And then let's go ahead and let's see how it goes. We're going to leave this enemy right over there, but we're going to put our player over here. So hopefully we'll get a nice cool route that will develop. Okay, so it's going, there it goes, it's turned, it's looking, and all right, it goes around the corner. We can kind of move it around, and as we'll see, it will actually kind of look around like this, and it will follow us. Now, if we put it on the other side of an obstacle, it will walk around, it will know to walk around that obstacle. In fact, it will know to turn around if it's actually shorter to get to it, okay? So this is really cool. I would like to actually visualize what's going on for you. Let's draw the path that the enemy agent has on its mind. We're going to draw something inside the scene to help us with visualization, help us understand what's going on. So we're going to use the function onDrawGizmos. Remember, this is the function you want to use if you want to draw any cool debug information into the scene view, like lines, for instance. Let's go ahead and set our color here. We're going to set our color to red, so it's really easy to notice our lines in the scene. We're going to go ahead and iterate through the vertices of our path. We can get the path that is on our agent's mind by doing this. Int I equals 0. I is smaller than agent.path.corners. Okay? You can think of corners as vertices. It's an array of 3D points that tell us where our path is going. So, there we are. There we go. That looks kind of ugly. Now we can iterate through here, and we're going to draw some lines. Gizmos.drawLine. The drawLine function requires two positions, two vector 3s, a from and a to position, and we can get both of those right here. We are going to grab our current corner, and then we're going to draw to our next corner. This is going to create an off by 1 error because we'll be reaching 1 past the end of our array, so we need to not go that far. We're going to put a -1 right here. So we're going to draw a line, and then we're also going to draw a sphere. We're going to draw a sphere at every single vertice. Okay? We want that sphere to be of radius 0.25, and we want to be at the location of our current corner as we iterate through this array. And let's go ahead and take a look. We'll compile here, so there we go. Come on, let's go. We'll play our game, and hopefully we'll be able to see a little line form. There we are, look at that. Look at that, and as we move around our target, the line updates every second to show us what the new plan is. If the if the path is actually obstructed by an object, we'll see that there's some vertices that kind of take us around that object, which is super, super, super cool. In fact, I kind of want to make this a little bit more complicated. Let's go ahead and get some zigzags going in here. Maybe, we'll create a little bit more, make this a little bit tinier. Shift the sizes here a little bit. Okay, let's make this a little bit wider. All right. So we can move our player over here. Our enemies over here. We'll go ahead and rebake. Okay, we'll rebake our level geometry because you can see that if you move something, if you create a new object, if you do the stuff at runtime, what will happen is the nav mesh will not update. We have to rebake by clicking over here to actually create the nav mesh that respects these new objects everywhere. And let's go ahead and add in another enemy. We'll turn this into a prefab so we can create many enemies if we want to. Prefabs folder, okay. And we will go ahead and drag our enemy in. There we go. Let's go ahead and drag a couple. No, how about just 2 for now? Okay, we got another enemy here, and now we'll play the game and see what it looks, see what kind of paths our AI comes up with. Okay, there it goes, right? And we can move our destination around here. They actually split up. That's very cool. So if you have a game that needs some pretty nice pathfinding AI, then, I mean, we got this going in like 5 minutes. It was a little bit longer than that maybe because I had to explain stuff, and that will always slow you down. But these are extremely, extremely powerful technologies that can get you up and running really fast, help you prototype your design ideas earlier, and eventually get to a much more engaging end product. So I think there's one more thing I want to tell you about. One of the big weaknesses here is that you have to actually bake the nav mesh. And wouldn't it be cool if we could make these blocks like move over time? And, you know, and still have enemies kind of walk around them. You know, maybe you've got a door in your game, and you want that door to be able to close and block enemies, and they'll path around it through other rooms and stuff. Or if the door's open, you want the enemies to go through the door, okay? Well, what you can do is you can use another component called a nav mesh obstacle. So let's say that we want this block to be able to move. Actually, let's create another one. Let's create another block. This is going to be kind of our obstacle block. We'll call it an obstacle. Okay, and we'll actually get it outside of our level geometry because it's a bit special. We'll put another color onto it as well. What kind of colors do we have here? We've got green. We don't really, that's for grass. So let's go ahead and create another color. Let's call this yellow. And we're going to grab and keep our color palette intact. We'll grab the green, we'll use it as the base for our yellow, and then just change the hue, okay? It's kind of a nice golden yellow. Okay, here we are. Let's make this block a little bit tinier. So how about like 3 by 3 by 3 maybe? We'll make it a little bit shorter even. Okay, so there's another component here called nav mesh obstacle that we can use, and what it will do is kind of during real time it will cut through our nav mesh and kind of reform it in the area where this object is. We have to select carve though, otherwise it will not update in real time as it moves. So what we'll do is we will go ahead and let's move these enemies over here, and then what's going to happen is when they route to us, we're going to try and block them with this yellow block, okay? Let's see what happens. I'll make the screen a little bit bigger if I can so you can see a little bit better, okay? So we'll launch the game. We will select our block here. We'll get ready to move it. Okay. Okay, good, good, good. And look at that. They saw that this block was moved in front of them. They rerouted, and now we move one block so it has decided to go back to its initial route, right? So it's really, 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 really powerful. This can get you going very, very quickly. And if you have a game that needs AI, whether that's NPCs following you around, whether that is enemies who have to chase you down and do damage somehow, then this is the kind of technology that you can just get you going super fast, okay? And help you explore your ideas and iterate faster and end up with a much better product at the end of it, okay? Does anyone have any questions before we take our break? I think we're going to take our break in just about a couple minutes here. So the last thing I'll let you know about is when it comes to implementing these kind of techniques yourself, these kinds of components, wondering how you would build your own. We actually did build our own at Arbor Interactive, and one approach that is pretty commonly used is A*. A* is an algorithm that is kind of similar to breadth first search, depth first search, right? It's a classical search technique. However, it is more optimized than those. What it will do is it will use heuristics to dramatically speed up the algorithm. Whereas breadth first search kind of selects all of it kind of searches all of the blocks on its frontier and then grows the frontier over time. And it's really slow and it takes a ton of memory to do that. And depth first search, which kind of just goes deep. It just chooses a direction to go into and explores in that direction all the way until it eventually has to come back. A* will say, okay, I can search north, east, south, or west. Which way is my player? Because that's probably the direction that's going to get me there the fastest. Not all the time, but probably it's going to be a good heuristic for us. So there are a lot of really cool algorithms that are kind of extensions of the ones you may have learned in 281, and they can be very effective. I encourage you to look into EECS 492, or if you're going to grad school, something like EECS 592, and you'll learn a lot. And these are really, really fun courses and fun topics, okay? At the end of the course, we will show you a really cool tool that allows you to experiment with like 10 different very cool pathfinding algorithms. Allows you to construct your own test beds for them and lets you analyze how many steps they take, how much memory they take, and stuff like that. Okay, so please look forward to it. All of that is in your web browser. Okay, so let's go ahead and I'll field questions. We got about 5 minutes. You can ask me anything you want about the projects, about the course, about this material. And then in about 5 minutes, we're going to come back with a lecture on scaling your production. So now that you are on your biggest team yet, a team of 5, what kind of tools and techniques and organizational principles do even larger teams use? It could be a little bit useful to you as you organize your P3 production, but is going to be very useful to you if you are interested in game development as a whole, or just even big tech companies. Okay? So I will see you in 5. We'll set the timer. We'll turn on the nice lo-fi study music back on. Yeah, so you do use things other than a star, but I think it tends to vary a bit based on what you're trying to accomplish. We can talk about some of that stuff later if you want to. A star is really, really great for 2D games. I think it tends to be a little bit less used in 3D games, but does anyone have any questions? What's everyone drinking? I have this is lemon chamomile tea right here, and it is yeah, it's pretty good. Even when it's not warm, it's pretty good. We got the Zen Greed tea going on. Awesome. Very cool. Oh, this reminds me. So Ishwar got in his feedback a really cool idea. It was the idea that we are all so remote, right? During a normal semester, we would like see each other every, several times per week. We'd play test all together in a big, exciting room, probably in downtown Ann Arbor in Spark Incubator. But during our pandemic, like you don't feel very connected to your classmates, do you? Like I know we feel that. Like we do not see your faces all that much. But these playtesting sessions are pretty awesome, aren't they? You get to watch people who you may have not even seen before play your game and give comments, and you just get you verify that, wow, yes, there are other real humans with real challenges and real hopes and dreams out there interacting with my game. It's really cool, isn't it? Yes. So our Sabata asks, is there a way to get essentially, is there a way to add a penalty to certain locations when the nav mesh system is deciding, okay, which route should it take? And the answer is absolutely yes. I don't use the nav mesh system all that much personally because we rolled our own, so I'm not exactly sure how you implement that, but I'm pretty sure it's very easy, and I think it would only be a quick Google search away. I imagine you'll probably define some bounding volumes that have a certain like negative value on them, a certain negative priority on them, and that will get baked into the nav mesh when you go to click that bake button. But yeah, like that's a very common thing. Like you could have a puddle of water that enemy AI can walk through if they're forced to, but they don't want to because it's super slow, right? You see that kind of stuff in all sorts of open world AAA games. So we got jasmine green tea, awesome. Hints of citrus and mint. All right, that sounds good. Mints are great flavor. Got about 60 seconds remaining. I'm drinking water. Good for you, Ish. Good for you. I went to the dentist not long ago, and my teeth were much better than they had been like in years prior. And they wondered, like, they were very pleasantly surprised. They wondered what had happened. And I told them that, well, I didn't know, but I had traded my Red Bull, I had traded energy drinks for tea. And tea is not great in a way because it stains your teeth. But the dentist decided they really didn't care about that, and they were just happy. They literally said they can't believe for once someone listened to our advice to stop drinking energy drinks, to stop drinking sugary stuff. And they were very pleased, despite my teeth being a little bit weirdly colored, I guess. It's okay. They're normal colored now, I think. I don't look at my teeth very often. Okay. Let's go ahead and get on with it, yeah? So I'll leave this audio going. Get that nice atmosphere. Okay. So, a little spoiler, we'll be watching something from the Halo 3 documentary pretty soon. Red Bull is just so much better at keeping you up than tea. Well, yeah, I agree. But I do think tea does a pretty good job once you've gotten yourself used to it, right? When you don't drink a ton of caffeine, you're more sensitive to the caffeine you do drink. So a bit of tea late at night can be enough to keep you up for a little while. Okay, everyone, let's talk about scaling your production. Or in other words, what kind of concerns are relevant to you as your team grows in size? And your team has grown in size pretty lately, right? It is now a team of 4 or 5, and if you were to join the Wolverine Soft Studio, which we'll talk about in just a little bit, then it would go from 4 or 5 to 30. Okay, that's a big jump. If you were to then go to work at a place like Stardock, a AA studio, you'd jump to a team of 60 or 70. If you then went from there to a AAA studio, you'd jump to a team of about 300, okay? So, let's go ahead and talk about how that happens and what's important when it does, okay? So, scaling a production. Let's talk about the team, right? Personnel, disciplines. We're going to talk about the tools and pipelines that are really helpful for larger teams. And we're going to talk about how teams get their resources to keep on living, keep on making cool stuff, and stay together. You've seen this image a few times in this course. A little reminder, this is an image of Braid during its development. This is the kind of single person, $0 down version of Braid. It was used to kind of iterate and prototype the game's design so that they could, figure out if they had a great design. And once they knew that they did, they could go and invest all the money and resources to make for a beautiful game. But in the context of a team, one person is going to struggle to make this. It is very rare that you find someone who has the time and all of the skills at a high level to create the art at a high level, to create the music at a high level, the design and the engineering at a high level as well. And so you will inevitably find yourself creating and forming teams if you want to reach this level of quality. And let's not just talk about this indie kind of scale of team, 3, 4, 5 people. Let's talk also about the enormous AAA studios that tend to be in the hundreds to 300 person, okay? You're going to need a lot of people, okay? You're going to need a lot of people with a very diverse set of skills. And so let's talk about those various skills. Getting disciplines that are so different in many ways to be able to communicate with each other, to be able to learn from each other and work together with low friction, it's a big deal, and it's hard. You can ask anyone on Wolverine Soft Studio, and they will tell you this, okay? If you go to EA Redwood Shores, which is the Electronic Arts corporate headquarters, I think it's like 45 minutes south of San Francisco. You will find on the second floor Maxis, which is the team that makes The Sims. And on this floor, you will find 2 boards. Here's one of them, the north side board. This is a really cool little means of organization that is very telling. If you look closely at this, you can see that it's kind of a layout, a floor layout, but it is also a ton of buttons. Okay, you can see that there are a lot of little circular objects here, and each one actually has a color associated with it and an image. Now, each one of these represents a person on the team, okay? And there's 100+ buttons here. Now, just doing a little bit of math, let's say that you assume a $50K salary, which would be the median salary in Michigan. A $50K salary times 100, right? That is $5 million for 1 year. But actually, this is the Bay Area, so it's much closer to something like 100 grand, okay? Multiply that by 100 and you get 10 million to have this team working for a year, okay? But wait a second, it's actually way, way more expensive than that because you have to pay for the actual office itself, okay? You also have to pay for benefits and stuff like that. So it's probably more likely, about 15 million per year to 20 million per year, and this is only half of the team, okay? So games are extremely expensive to make, and this weighs on publishers greatly, which is something we'll talk about during our games and business lecture a little bit later. So if we zoom in on this image, we can see that you can make out the colors here, right? We got a bunch of red colored pins, we got some blue colored pins, we got some purples, some golds, and just a ton of reds, okay? If you look really closely, you can see me right there. Right there is my little button. And the question you might ask is, okay, what do the color codings mean? And more importantly, why are they mixed together? Why isn't it just a sea of red, and then maybe somewhere else you have a sea of blue, a sea of purple, the gold? So gold were producers, okay? These are the business people, the people who are responsible for kind of keeping everyone on track and allocating their resources in a good way. The blue is an embedded Q&A tester. So this is someone who you can turn to at any moment and say, hey, I just finished a feature. Can you pull that feature to your version of the game and can you test it? Can you make sure the game still runs? Can you see if you could break it in any way? Purple were the game designers. These are the people who would actually work with the tools that we created to put content into the game, okay? And the red were programmers and engineers. The engineers on this side were UI engineers, and the engineers kind of on the bottom in the middle were gameplay engineers, which is what I was. And so my first question for you, chat, and I'd like to hear your ideas. Why would you mix up all these colors? It looks like our designers have been like stranded in the middle of a sea of programmers, right? Why isn't the Q&A tester put way over with the other Q&A testers in like their own little wedge of the floor space? Why is this mix happening? Wouldn't that be frustrating? Like, you want to be around your discipline, right? You got to talk about art things if you're an artist. You got to talk about engineering things if you're an engineer. So Gagin says, you would do this mixture because sub-projects are actually multidisciplinary, right? So the knowledge that flows down through your department, right, that's going to be great to talk about and all of that. But when it comes to actually creating a new feature, when it comes to creating a new area, creating a new tool, creating a new design, a new object that can do new things, often you actually need a bunch of different disciplines to work together, okay? And so if we have a gameplay engineer over here that's working on a certain feature, and they don't really understand what this new object is supposed to do in the game. They sort of understand it, but it's kind of unclear, and it's sort of blocking them from finishing this code that they're writing. What they can do is they can walk over to one of the designers that is right next to them, and they can say, hey, this feature, I don't understand the spec, it seems ambiguous, what should I do here? The game designers now have a link. They can either provide the answer, or they can quickly get an answer from their design lead, right? Designers have easy access to the design lead, more so than the engineers. In a different way, if a designer is coming up with a really cool new design for a new object or interaction, and they don't know if it's actually possible, what they can do is they can say, hey, engineer, right? Engineer walks over and they discuss the design. They say, oh yeah, I think that's going to be possible. We can implement it with this and this. Or, no, I don't think this is going to be possible. We can do this and this instead. We can refactor your design in this way. And so this is essentially called the pod design, pods. It's not a department. A department is one discipline, right? Like art or engineering. A pod is a group of people centered around an objective. And usually that is a multidisciplinary set of people, because that's what it takes to complete an objective. So anyway, okay, let's keep going here. It takes a lot of different disciplines to make a game, right? You know this, and we need them all to work together in harmony and be efficient, okay? If you are part of Wolverine Soft Studio, or if you end up joining Wolverine Soft Studio, then you'll discover this very, very quickly. In fact, if you go onto this 30-person team, which you can get credit for, then you will find yourself part of this Discord. You'll see that there are a lot of different departments that try and get communication and knowledge to their members. But there are also a lot of different pods centered around certain objectives. So you might be an artist, and you might be a part of the art department, but you also could be a part of the user interface department, which is going to be a group of maybe 2 artists, 2 engineers, and 1 sound person, right? 1 audio person. The result of this is that discipline knowledge flows to other disciplines because you're always in proximity. It isn't just the engineering is way over here and they never talk to the artists, which are over here, who never talk to the level designers, which are over here, right? You have your department's knowledge and you have meetings with your department, but you also have meetings and knowledge from the other disciplines you interact with via your pod, okay? This organization can be extremely effective for large teams, and the Wolverine Soft Studio has found it to be a pretty efficient approach, okay? Talking about art, right? Talking about each discipline and what they tend to value and what challenges they run into, right? The art discipline, at the very low level, you might find yourself maybe even on this project using Microsoft Paint, okay? The classic, ready-to-go tool for making aesthetics. This is actually a problem, though. Microsoft Paint does not support alpha transparency. And so, if you make any aesthetics that aren't a block in Microsoft Paint, then you will end up with these really awful-looking white backgrounds. So that's why many people prefer something like Paint.net. It's an extension of Microsoft Paint that supports things like alpha transparency. As you find yourself kind of working your way up, you'll find that your teammates or maybe even yourself are starting to use programs like GIMP or Krita. These are free alternatives to otherwise paid software. So GIMP is a really cool Photoshop alternative. Krita is really, really good for painting. You might also throw Illustrator in here, right? And actually it's alternative, Inkscape. Inkscape would be right in here. On the high level, if you get into AAA, or if you join the Wolverine Soft Studio and you use the University of Michigan software licenses that you're afforded, then you might do something like use Autodesk Maya. You might do something like Photoshop. You might use Illustrator. For now, if you want to do 3D artwork, you probably want to use something like Blender, okay? Blender is a really, really powerful piece of software. It used to be much harder to use and get into. It was very, very kind of shortcut and hotkey heavy. But now it has a reasonable interface. I'm sorry for anyone who liked the previous one. I really didn't. It's fairly easy to use now. Okay. Engineering. This might be of interest to you. When you are getting started with game programming, what many, many, many people will do when they're young, even, is they will use drag and drop visual programming solutions, sort of like Scratch. So you might not have seen this before, but MIT Scratch has a visual programming approach, which means that you don't actually code like lines of code. You don't write lines of code. What you do is you take the blocks that represent functions and you kind of stitch them together, okay? Let's see an example here. Here we go. Like if you're trying to write logic for a new mechanic that you had designed, What you might do is you might put together a bunch of blocks to make that happen, like what you can see here. Okay, what does this person end up putting together? Let's see if we can figure out what they're trying to do. So this person wrote some code. Oh, I can't quite read this. The green flag means when on start. I can't read. Yeah, I can't read Spanish. Sorry. Anyway, some of you can. But basically, all these blocks are like if statements or function calls that do various things, like move an object or play a sound. This block right here says, hey, when the game starts, begin executing, and then just go down this list until you run out of things. You can implement for loops here. There are blocks for for loops. There are blocks for other stuff. It's really, really cool. Anyway, this is a great way to get started in programming. You don't have to remember all the keywords that do special stuff. You don't have to worry about accidentally typing a semicolon. You just drag and drop, okay, from a toolbox that you can study to learn what options are available to you. Okay, moving on from MIT Scratch, you get to a still beginner-friendly ecosystem in GameMaker, but one that's pretty powerful, okay? You will not find any mainstream commercial successful games in Scratch, but you will find them in the next step up, which is something like GameMaker. So GameMaker is the technology, it's the game engine that was used to create some really cool hits like Hyper Light Drifter, which you see in the corner here, Hotline Miami, Nidhogg, and games like Undertale, okay? So GameMaker is a really, really powerful solution, but it still has the drag and drop coding approach as Scratch. It also has an actual text language that you can use if you don't want to do drag and drop as well. Taking a step up from GameMaker, we get to a still fairly beginner-friendly game engine that is much more powerful. It can do 3D, it can do 2D, it can make games that really do look great. Unity is the engine we use in this course, and one of the reasons why is because it is powerful enough to put out impactful games that look pretty good, but it is beginner-friendly enough to take students from zero to competing for internships within like 3 or 4 months, okay? And this, we've already talked about this, but this is an engine that supports some of the most popular games in the world. It supports Hearthstone. It is the game that Recore was made off of, a beautiful kind of AAA game. It makes a ton of indie games like Overcooked. And so it's a pretty darn good middle-of-the-road choice for people who want to get started with a game engine. Now, stepping up from Unity, we have an engine that you might have heard of. It's called the Unreal Engine. It was created by Epic Games and a long time ago, actually, I think in the 90s. And it was it currently powers like some of the most beautiful AAA games the world knows, including Fortnite, right? The world's largest game. It has powered games like Bioshock Infinite. It also can support smaller and medium-sized games like Rocket League and even mobile games like Infinity Blade. And so it's really, really interesting. It's often said that Unity is a really, really great choice for kind of smaller games, mobile games, and medium-sized games, but it can sort of do larger games if you really want. Unreal Engine is well known for supporting AAA games, medium-sized games, and it can do small games and mobile games if you really want it to. Now, if you want to go beyond Unreal Engine, then you get into the really secret and spicy stuff, okay? There are a lot of companies out there that kind of live on the bleeding edge, and that is their entire purpose. You often see this in first-party games. Naughty Dog, for instance, right? The famous Sony PlayStation first-party studio, they are responsible for making games that cannot be made or found anyplace else, right? And as a result, their games are absolutely breathtakingly beautiful and in many cases photorealistic. And these games are beautiful on hardware that is extremely cheap, right? Consoles are not powerful computers. They're cheap commodity computers, okay? People buy consoles because they don't want to pay up for a gaming PC. They just want something that can play games, and they want it on the cheap. And so as a result, consoles tend to have very cheap and slow processors. They tend to have very cheap and slow graphics cards in them. But the first-party studios like Naughty Dog, like Sucker Punch, like Nintendo, they still have to find a way to make this cheap hardware sing. And that is often through extremely optimized and smart software and lots of innovations in that space. The thing, though, is that Naughty Dog would lose its many of its strengths if it stepped down and used Unreal Engine. Naughty Dog has to customize their engine to be really efficient on consoles, and in particular the PlayStation family of consoles, because that's the only place they release their games. And so they can't use other game engines. They have to have their own that they can heavily customize to get their job done. Other companies will do this too. EA has their Frostbite engine. Frostbite was initially made, I believe, for Battlefield, that kind of a wargaming series. And the Battlefield series is famous for having destructible environments. So if you have an opponent that is inside of a building and they're hiding from your gunfire, then you can jump in a tank and you can shoot down the wall of their building, and then they've lost their cover, right? In order to support that, they had to build their own engine that could manage that level of damage and detail. And so they couldn't really use other engines. They had to go and make their own from scratch, and now that is their competitive advantage. They have this proprietary secret technology that you will only be using if you get hired by EA, okay? And then you've got companies like Bethesda that are very known for building humongous big worlds. If you think about Bethesda in games like Morrowind, if you wanted to explore an enormous world that was still very detailed and full of content and quests and NPCs, if you wanted to explore a huge world in like the mid-2000s, Bethesda was one of the only companies doing that and doing it pretty well. The way that they were able to do that was by kind of having their own game engine that was built specifically for that purpose. And so while big open world games might be common now, they weren't back in the day. And Bethesda, as a company, benefited a lot from the fact that they had their own game engine. Okay, so let's keep going. Yeah, proprietary engines are super cool and very fun. But yeah, they can be a little bit hard to work with, particularly because with Unreal, so many people use Unreal that there's a ton of good documentation out there. There's a lot of people who are trained in Unreal. And so you can always find good talent that can use this game engine. Anyway, all right. However, because you use this game engine, all of your competitors get the same technology that you have. So you're not going to differentiate yourself on your technology if you choose to use this game engine. All right. So let's talk a little bit about game designers. So game design. One of the biggest tools that game designers end up using happens to often be notebooks. We talked in the past about how valuable it can be to sketch. The idea that a game designer, one of their main purposes, is to not only come up with ideas and come up with philosophies to guide their level design and characters with certain unique abilities and good themes, a game designer also has to communicate all of these good ideas, right? And if they can't get a team to understand what they're going for, if they can't convince their teammates, if they can't get the buy-in necessary, then their best ideas don't happen, and we end up with a game that just has really plain, vanilla, average ideas, okay? So here is another example of a sketch, a notebook drawing that was very pivotal for a very pivotal game. So the question, Chad, I have for you is, what game is this? I'm on the right here. What game is this a sketch for? Any ideas, chat? It should look familiar to a number of you. Bingo. Bingo. Mandelbrot has it. This is Undertale. This is one of the first sketches that Toby Fox made, kind of detailing Undertale and what the gameplay and battle system was going to be like. Right? You've got this act menu where you can go in. You can choose a bunch of different things. If you choose talk, you can choose many different ways to talk. Right? And stuff like that. So yeah, if you're a game designer, you are going to be using different tools and mediums to get your idea across to your teammates. And this is something that you should do if you happen to be the design lead or participating heavily in the design on your team, your P3 team. Game designers make heavy use of wiki software, often Confluence or something like MediaWiki, which is free. Essentially, you can install MediaWiki on your own servers, and this gives you your very own copy of Wikipedia that you can edit and fill with your game mechanics and your stage area ideas and stuff like that. Excel can be an extremely good way, and Google Sheets, spreadsheet software, can be an extremely good way to kind of organize your game mechanics, to balance them. If you have 5 weapons in your game and you don't want any of them to be OP, right, and unbalanced and dominate the rest, then you might want to be able to do some solving, right? You might want to be able to equate all these weapons through some sort of formula. Maybe you create a weapon value score, and the score is the number of damage, my dog's barking, the number of damage multiplied by the speed at which you fire shots, right? Multiply or divided by the cost that weapon takes to acquire or something, or the fragility of the weapon or something like that. And then you could use all of these attributes and lower them and increase them for different weapons to try and get the value of each weapon to be about equal. That would suggest that the weapons are kind of in balance, all right? So spreadsheet software is super, super useful, particularly if you don't have 5 weapons to balance, but you have 500 to balance. A lot of larger games, MMO games, have that kind of quantities that they deal with. So anyway, here's an example of using wiki software. My company used to use MediaWiki, and we would put different design documents in there. We would put different technology explanation documents in there. This all becomes way more useful as your team grows. So if you want to, you can actually watch. I found the original The Sims design document online. You should be able to grab this and read it if you want to. It's kind of interesting, but a bit dense. Concept art is a really, really powerful tool for the designer. Now, we already talked about this, right? You already saw Rian Johnson's sketches for The Last Jedi that he used to convince his team it was going to be okay. You've already seen my sketches, right? Maybe you go to your team and you say, okay, here's the idea. We're going to put a drone inside of a bat cave. It's going to be awesome. It's going to deliver bugs to the bats, and it's going to protect them. They might think you're crazy, right? They might think, oh, this idea sounds awful. You might give them so many details and drone on for so long that they can't even picture it in their head anymore. But if you have a sketch, right, and they can see, oh, it's a futuristic drone, so this is long into the future. Okay, that makes sense. We got really good technology that's not going to hurt the bats. It looks pretty good. It looks like a drop of honey, right? They might be much, much, much more convinced if you can bring them some sketches, okay? And blah, 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 blah. We already have all this stuff. We've gone through this before. We're just going to skip through it. Blah, 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 blah. Okay, bye-bye. What? All right. Let's talk about business and production. This is Andrew Wilson, the CEO of Electronic Arts. And his main role, if you think about it, is mainly to acquire resources and to make sure those resources are being allocated in ways that are going to get the company more resources, okay? Producers often make use of spreadsheets and Excel, particularly if they are on small indie teams. These are free resources, and they are pretty effective. You can measure your hours that people are spending and how much hours you think you need to spend, and there you go. You know whether you're ahead of time or not. You can use software like MediaWiki that we just talked about to organize stuff. You can also use technologies like Redmine. Redmine is really interesting. It's essentially an open source Jira, and we used to use it for this course until we got an educational license for Jira, and then we wanted to make sure that you were actually using the exact software that you'll be expected to use on your internships and in industry. So we moved to Jira. The big one, of course, is Jira. And it can be extremely useful, as you've discovered, and as you'll soon discover, to kind of keep big teams on track. Make sure that you're allocating your talented individuals to the right assignments. Make sure that they are putting in the hours that they're expected to put in. Make sure that the team is roughly balanced. Make sure that you're not too behind the schedule. Make sure you're not too much ahead of schedule. and just keep track of what needs to be done, right? If you think about music, music is an extremely big deal. This is Koji Kondo. If you might not have played Super Mario Brothers in a long time, the original NES game. You might not remember exactly how the physics felt, but I can guarantee you remember da 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 ba 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 da da ba da da ba da ba da da ba 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 da, right? Audio is what often gives our games the most emotion. It often gives us the most juice, the most bang for our buck. And so it is worth investing in and worth thinking about. You'll have to do a lot of it on this P3. It's a big part of your project. When you are getting kind of introduced and started with audio production, you'll probably be doing several things. You'll be using stuff like Audacity to edit, a very simple, very free program. You'll be using simple DAWs, it's called, digital audio workstations like GarageBand, that come with a bunch of pre-created loops that you can use that are free and easy to access if you have a Mac. And you'll be using a lot of asset packs, okay? In fact, some of the indie games with the best audio, what you'll discover is that they weren't necessarily good at producing music themselves. They were really good at finding it and integrating it into the game. So you'll want to go to opengameart.org. You'll want to spend an hour or two kind of just going through that website, using the filters as best you can, to try and find these different tracks that have a different feel that you're going for. You'll want to go to freesound.org, which has just a crazy amount of audio files, and many of them extremely high quality. You just have to find them. So one weakness of using asset packs is that if you use them too much, what you'll find is that it will distract your players, okay? If you take the main character in your game and you pull that character out of an asset pack, and then your player happens to have played a game that used that character but as an NPC, your game is going to really start to feel very cheap. It's going to feel not original. It's going to feel boring. So asset packs tend to come in and be most effective when you use them on things that are going to receive less attention, things that need to be there but are not going to receive much scrutiny. So things like trees, things like rocks, can often come out of an asset pack with basically no loss of originality, no issue for the developers. Okay? So you're going to use a lot of assets from the wider internet in this course. And you still need to think about, okay, what do I need? Does this work? And how can we kind of fashion it to work? Whether by editing the textures online, editing them in Audacity, the sound effects, placing them in the right location where they're kind of dark and won't be noticed, and other stuff like that. Okay? If you want to start composing and producing your own music, and you want something that's more deluxe and more interesting than GarageBand, the free Linux Multimedia Studio is a really cool piece of software that comes with some really, really great synthetic sounds. Even though it's called the Linux Multimedia Studio, there is a build for Mac and Windows. I think Mac. I think there's one for Mac. I encourage you to check it out. It's really, really cool. If you become a professional, AAA audio producer, or if you join the Wolverine Soft Studio, you'll probably be using one of the deluxe Hollywood-style packages, like Fruity Loop Studio, or Ableton, or Pro Sound Effects. And these are really, really, really powerful and very, very, very cool, and can be very, very nice to use. But they are not free unless you are here at the university, so when you leave the university, when you graduate, you might lose access. Yeah, they're really, really impactful and very cool, okay? And yeah, you've already seen this. At the highest levels of music production, you have full bands, you have full orchestras, incredibly talented people in mass in a room playing in harmony, and it just sounds absolutely incredible. But many, many games never quite reach this level of budget, and that's fine. One of the, I wish more classes had access to Jira. I discovered it's actually not that hard. You just have to ask them, and they'll send you the codes. So yeah, we had to poke and prod them a little bit, I guess, but it wasn't too hard. One of the most interesting things you'll discover as your teams get larger, and this isn't just a game company thing. Maybe you go and you work at Google and you start on like a small team at Google that's doing some tiny niche stuff. And then you do a good job and you decide you want to move to the biggest teams at Google, like search or ads. What you'll discover is that what it means to be an engineer at a startup or a small team, it means something totally different to be an engineer on a big team. For instance, you might be an engineer on a startup, and that's just your title. You are an engineer or a junior engineer. And any technical issue that faces the startup, no matter what it is, it's going to come to you, and you have to deal with it. You have to wear a lot of hats, in other words. However, if you join a team like the Sims 4 team at EA, you will not find yourself as a generalist engineer. You'll quickly find yourself becoming a systems engineer, right? So working on low-level code that is extremely performance intensive. You might be working on the underlying rendering engine tech. You might be working on the underlying pathfinding technology, the AI tech. You might find yourself a gameplay engineer like me, where you are right next to the designers and you are implementing tools and technologies and game mechanics, making sure they feel good, and then handing them off to the designers for verification. You could find yourself an AI engineer, a tools engineer, a technical director, someone who is out there kind of trying to figure out, okay, what kind of futuristic technologies can we integrate into this game to give us a leg up on our competition? Can we integrate machine learning into our AI? The answer is no currently. It almost never works. But that's the kind of stuff you might do as a technical director. An artist might find themselves handling almost any visual or audio aspect at a startup. But on a big team, you might become the concept artist, someone who's generating 50 concept sketches for every new character in the game, right? Just to make sure that no idea is left unturned, no stone is left unturned. You might be a 3D modeler who's the one creating the meshes for these characters. Maybe not even the textures, maybe not even the rigs. You're just doing the gray meshes. You might be an animator, the person who takes the mesh and just gives them motion that looks charismatic and effective. You could be an environmental artist, so you're the one who's dealing with how the grass works, right? And how to keep that performant but also make it beautiful and reflect the lighting and all of that. You could be a character artist, a technical artist, writing shaders and kind of building some of the technical tools for artists. There's all sorts of things you could do. Team, have I told you about the hand guy, the story of the hand guy at Visceral Games? Okay. So I'll tell you the story of the hand guy. So when I was at Maxis, like right above us was Visceral Games. And I think they were working on Battlefield Hardline at the time. They had just gotten done with Dead Space 3, I think. Anyway, at Visceral Games, there was a person, I can't remember their name, who was one of the most prolific creators of hands in the entire world. This is someone who knew how to rig hands, knew how to texture hands, knew how to model and animate hands. If you need the most perfect hands for your games, this was the guy you had to hire, okay? Because all this person did was hands. That was it. They went into their office in the morning and they just thought about hands all day. They didn't do anything else. They didn't contribute to any game design, unless it involved hands. They didn't contribute to any other systems. They didn't program at all. They didn't do any other models. They only did hands. That's the level of specialization you can find yourself getting into if you are on a humongous team. Many people, like me, don't really like that level of specialization. In a startup, a small team, you end up getting a much more varied body of knowledge and much more varied body of challenges. But you have way less security as a result. So that is the story of the hand guy. That is to say, all of these disciplines, from art to engineering to music to business, they can all be broken down a lot and made much more specific. And as you jump onto larger and larger teams throughout your career, this is very likely what's going to happen, okay? So ask yourself whether you really want this. When you go to join Sony, you should probably know that there's a very good chance you're going to be a bit of a cog. You're not going to be the one implementing the big, crazy new mechanic that you love. At least not at first, okay? You're not going to jump onto a project, a company like that and be Kojima. If you want to be Kojima, you have to create your own startup, and then you've got all sorts of problems to deal with. including resources and paying the bills and whether your game's going to be any good in the first place. Okay? All right. So we're getting toward the end of the lecture here. The takeaway is that, gosh, games are really, really an interesting, special thing, aren't they? Like it's not like a normal tech company where, you might have a bunch of engineers and some artists helping you out, some UX designers helping you out, some producers, and maybe those engineers have their own niches, right? Some are doing AI, some are doing back-end work, some are doing front-end. But when you think about games, you really have to take these crazy different disciplines, and you have to somehow find common ground. You have to reduce the friction between them, and you have to turn those differences into a positive. And I want to show you an example of where this absolutely happened. The making of Halo. This is a really cool documentary. I'm going to show you about a 5-minute clip from this documentary. This clip in particular goes into how engineers on this team and how artists on this team kind of played off of each other and inspired each other in turn, and how that was just incredible for morale. The different disciplines coming together to embrace each other and create a fantastic game as a result. Let's go ahead and take a look.
Trying to cram as much stuff in as he can.
Every now and then, it'll catch my eye still. Wow, I can't believe we were able to pull that off.
Games are nothing without suspension of disbelief, of you losing yourself in that environment.
They're creating fantasy world, but even fantasy world has some resemblance to real world.
If water looks like water and rocks look like rocks and explosions look like explosions, then you are engaged in the plot at a much more visceral level.
The way that the engineers and the artists work together is one of my favorite things about Bungie. You've got these insanely brilliant mathematical types that are really passionate about this new technology.
There have been a lot of ideas that have started from the engineering side, where an engineer said, hey, there's this technology I know how to use, or there's this thing I think I can do.
He definitely had a long-term vision about the graphics system. He had some fundamental ideas early on that he thought were going to be really important.
Halo 2 had a water system that looks really good, but it has a lot of limitations. It's pretty convincing from a high angle, but when you're at eye level, the effects breaks down. We were not actually rendering water as geometry. In the beginning, we'll have to do a little bit of selling. We have to say, hey, look at this cool water.
It's going to be awesome. We're going to do weather, we're going to do water. And the artist then gets extremely excited.
The Halo 3 is based on a new platform of Xbox. So in the new generation, we make the water surface animated.
You can interact with it, you can throw things in the water, and it creates ripples, and it looks great.
Probably the most fun thing about the water is that the bodies float in it. So you can shoot people and watch them float downstream.
When we first began our endeavor with building interactive water for Halo 3, we had given examples of small pools of water, little streams, rivers, and that kind of thing.
We just freshly deliver the water, and then the water happened to have ocean waves on it.
What it turned out that we needed a lot more of was small creeks, babbling brooks, or rushing rivers.
Water's pretty tricky. My first attempt yesterday was pretty bad.
I think it's cool.
You think it's cool?
Yeah.
Tell Marcus you think it's cool.
Marcus complaining about it.
Ocean waves in a stream? No, it doesn't work at all.
You want every creation you make to be beautiful, but with limited budgets, it's hard.
If you're trying to integrate some cool things into the game engine, you have a pretty limited budget.
You have to be really strategic with how you plan your assets that way.
So she will create a version of the water tool, and then we'll try it. There'll be some things that we want to use differently from an artistic perspective, and so we give them feedback.
Our water shader is pretty highly customizable. The artist can change the murkiness, and you also can change the color of the water. You can change the transparency and the sharpness of the wave.
We also have ways for them to paint different parts of the water parameters.
And then the engineer looks at it and goes, oh, wow, I never thought you'd be doing something like that with my system. But that's so cool looking that I want to make a better system for you to do that.
And nobody knew what it was going to turn out like. And then when it came time for the beta, which is when it really, came together, it was awesome.
pretty soon that you see water shows up in
All right. So if you didn't catch it, the idea was the engineering team, right? They had some new technology. They thought they could do some water. They had a first crack at it. And, you know, it wasn't amazing, but the artists saw it and were able to take it and do really cool stuff with it. The artists doing cool stuff with the tool that the engineers made inspired the engineers. Oh gosh, that's amazing. Let me make a better tool for you. And the artists see that amazing new tool with new features and functionality. They then take that new functionality and make something even better, right? And it's this positive feedback loop that starts rolling, where instead of being brought to a halt by the friction and the differences and the misunderstandings between departments and disciplines, instead you have the opposite, where the departments are coming closer together by their shared goal of making awesome water. They're inspiring each other, morale is sky high, and you end up with a fantastic game like Halo 3. I played that game a lot in my childhood, I'll tell you that. That is just about it, everyone. We'll talk a little bit more about this when we come back on next Wednesday. But in the meantime, I wish you good luck. You are working currently on your P3 milestones. This is the first deliverable that's going to have guidance. It's going to have interesting decisions. It's going to have those other criteria on it. And so you got to knock it dead, all right? And we know you will. So good luck. I'm going to stick around for about 5 minutes, and I'll answer any questions that you might have. We'll listen to some more chill music. And otherwise, I can't wait to see your deliverables on Monday and get you your feedback thereafter. Thank you so much for joining us, everyone. I wish you good luck, and we will see you next time. Bye-bye. All right. We'll head back to our lecture plan here. You can get to this document from the schedule. I've already posted it in here. I think right here. Yep. And yeah, here we go. It's amazing the power that audio can have on your mood. But maybe in a way it's really not that surprising. The idea of a drummer boy goes back a long way, doesn't it? The idea that you would use a drummer boy and rhythm and audio to signal not only commands to your troops over a large distance, but also you try and rally them, right? The military tunes being very full of spirit and energy, as they are. No problem. You're welcome. Gagan says, meanwhile, the water in Cyberpunk 2077 is like 2001 quality. Yeah, I'm sure they could, I'm not sure what the Cyberpunk water looks like. The game didn't really interest me. But I'm pretty confident that water was maybe not their chief concern. You know, maybe other parts of the rendering challenge kind of took budget away from the water. So we know how to render really cool interactive water, but if we do that, it's taking budget away from our civilians. Well, probably not civilians, but it's taking budget away from our building rendering, our materials that we find on like the sidewalk and stuff. I don't know, on the building sides. Yeah, I think they bit off more than they could chew. Yeah, a little bit, maybe. Yeah, I've watched videos that point out that really, like, comparisons are very unfair because Cyberpunk is going to get compared to, like, GTA because they are in kind of similar genres and they both try and do a similar thing. They're both trying to create a real-life, city. But, like, Rockstar has been doing that for, like, ages now. CD Projekt Red didn't have any humongous cities in the Witcher series, did they? I mean, I know they had some cities and villages and towns, but I don't imagine it really compares. I haven't played any CD Projekt Red games, so really hard for me to say. I probably should, but the Witcher series is not the kind of thing I think you can get into, like, over the course of a week. I think you need a good summer to dive into a game like that. Yeah, I've been playing a lot of Mega Man lately. Those are not very long games, but they are very hard, and they have some very interesting ideas, even if over the course of the series they are mainly pretty samey. Okay, I think that's been about 5 minutes or so. Everyone, thank you so much for joining us. I wish you the best of luck on your P3 milestone. Charge into it, right? Build up some morale on your team. Play some games together. Hang out together, okay? While you do other homework for other courses, maybe. And or maybe get online and play some Left 4 Dead together. Play some Garry's Mod. I don't know. Otherwise, good to see you all. Take care. I hope you have a fantastic, safe, and healthy weekend. All right? Rest up a little bit and stay productive. Take care, everyone. Bye-bye.